Lesson 5.3, Simplify Expressions. Take a look first at the solve and discuss it. How could you take those tiles and sort them into groups? Try this now and then come back and check to see if your groups match the ones that I created. While there is no one correct answer for how to categorize these tiles, I sorted mine into 3 columns. Okay? In the far left column, you see that each of those tiles is just a single number. We have a couple of fractions, and we have a couple of decimals and a whole number. We call these terms our constant terms. Then in the middle column, each of my terms has the variable x on it, so we're going to call these the x terms. And in the far right column, we have our y terms because each of those tiles has the y variable attached to it. Now, you may have sorted your tiles differently. Perhaps you sorted them into 2 groups according to the coefficients, such as positive and negative. Or perhaps you sorted them according to whether they were fractions or decimals. In any case, just make sure that you label your groups so that you know what the identifying factor was in your sorting mechanism. Take a look at the I can statement for today. Our I can statement says, I can use properties of operations to simplify expressions. And we're going to continue to work on simplifying expressions throughout this lesson. Go ahead and move on to example 1. The essential question that we hope to answer says, how are properties of operations used to simplify expressions? So now take a look at example 1. Combine like terms with integer coefficients. The good part here is that we are going to be using integers only for this first example. So take a look at the algebra tiles that you see spread across the desk there. A teacher used algebra tiles to model negative 2c plus 3c minus 5 minus 4c plus 7. Simplify the expression. So each of those tiles, you can see, represents a different piece of that expression. So the first starts with negative 2c, and you see you have 2 of those negative c's there. The second term says 3c, or plus 3c, so you see 3c terms as the next term. Then you have subtract 5. Well, subtracting 5, remember, is like adding a negative 5. And you can see that you have negative 1 tiles there, and there are 5 of them. Then the next term says minus 4c. Again, subtraction is the same as adding the opposite. So we have 4 c's there, and they're all negative. And then the last term is plus 7. That's a positive 7. So you can see we have all single tiles here, and there are 7 of them. So we have 7 single tiles. We have negative 4c tiles in front of that. We have negative 5 in front of the 4c. Then we have 3 c's and negative 2 c's. So each of those components of the expression can be written in picture form. Now let's take a look at the steps in order to simplify. We can read or write the expression by grouping like terms together. That means using those commutative and associative properties to reorder the terms and put the like terms together. So here's how they did that. They took all the terms with the c in them, and they wrote those at the beginning of the expression. Then they wrote the terms that just have numbers. We call those constant terms. And they combined those terms together in order to create a more simplified expression. So if I put negative 2c's and negative 4c's together, I have negative 6c. And then if I add positive 3c's to it, take a look at what happens over here in the picture. Notice that the 3c's matches up with 3 of the negatives, and what you have left is a negative 3c. Then you put together your numbers. A negative 5 plus 7. And again, every time you have a positive and a negative one together, they make 0. That's that opposites that we learned about back in topic 1. So what's left are 2 additional positive 1 tiles, so you have a positive 2. This simplified expression for what we started with, negative 2c plus 3c minus 5 minus 4c plus 7, can be simplified all the way down to negative 3c plus 2. I'm going to show you another way to do that over here on the side of your paper. The strategy that I'm about to show you is just another way to group the terms together without having to rewrite them all the time. So let's start with all the terms that have a C in them. What we're going to do is box around each of those terms and include the operation symbol in front of that term. So you can see that I boxed out a negative 2c, a 3c, and a negative 4c. And those are the 3 terms that I'm going to put together to get the new term that has a C on it. And that new term, let me turn that black, there we go. That new term with a C on it is what we get when we add negative 2 plus 3 minus 4. So what do we get when we do that? We get a negative 3. That's the coefficient in front of C. Then I'm going to take whatever terms are left and look to see if they have anything in common. In this case, they do. We have a negative 5 and a positive 7. So negative 5 and positive 7, when I put them together, I get a positive 2. So this is my second term. Since we have now used all 5 terms and combined the ones together that are alike, we can simplify this expression using those 2 terms, negative 3c plus 2. It just saves you a little bit of writing, but it's not wrong to do it the way that the book has shown you. It just requires a few extra steps. Now let's take a look at the triad expression. It says simplify the expression negative 6 minus 6f plus 7 minus 3f minus 9. I'm going to ignore the boxes over here on the right side for a moment. I'm just going to ignore that. Don't cross them out, but just ignore them. And I'm going to go through the expression as it's written here, and I'm going to start by circling any term that has the variable f with it. Now remember, I'm going to also circle, let me try that again. I'm going to also circle the operation symbol in front of it. All right, so what I have is negative 6f minus 3f. And what I get is a negative 9f. Now I'm going to move on to the other terms. I see that the rest of the terms are just numbers, no variables attached whatsoever. So I'm just going to add together negative 6 plus 7 minus 9. And what do I get? I get a negative 8, which is subtracting 8. So my simplified expression would be negative 9f minus 8. Now, you might be wondering what the boxes at the top are for. I think what they did here is they were looking to reorganize those terms using your associative and commutative properties and attempting to show these with the terms grouped together. So here's the terms with the f in them, and then here are the terms that are just constants, just numbers. Let's move on to example 2. Example 2, combine like terms with rational coefficients. We did a little bit of work with this in the previous lesson. Remember that when you simplify rational coefficients, that means rational numbers that are in front of the variables, you have to make sure that if they're fractions, you have a common denominator, and if they need a coefficient of 1, that you put a 1 in front of that variable, unless there's already a number there. So in this first example here, you see we have a hot mess of numbers. Negative 3 plus 1/3 x plus negative 4 5/10 minus 1/5 x. So we've got all sorts of numbers here in all sorts of forms. We have whole numbers, fractions, and decimals. So again, the book is going to teach you to reorganize those numbers using your properties by putting together the x terms, like they've done here, and I'm just going to circle them up in the original problem, and putting together the constant terms, in this case, the number only. So I see there and there. Again, you can do this whatever way best fits you. I try to save myself some steps, so I reorganize things by using circles and underlines, or boxes and circles and underlines, in order to make sure that I can put those common things together. So I need to first do the 1/3 x plus a negative 1/5 x. Okay, I changed that subtraction to adding the opposite. And of course, I need to get a common denominator. So the common denominator is going to be 15. So 1/3 x is the same as 5/15. And then a negative 1/5 x is the same as negative 3/15 x. And 5/15 plus a negative 3/15 is 2/15 x. So remember, when you add fractions, you're just adding the numerators. The denominator stays the same. So there's my term that just has the x in it. Then I can go ahead and, of course, use my calculator to help me with the constant terms. Negative 3 plus a negative 4 5/10 equals a negative 7 5/10. There's my other term. So then I just have to put those two back together in an expression that shows the 2/15 x minus the 7 5/10. Okay. Now I'd like for you to complete each of those two try-it questions below example 2. Pause the video while you do this, and then come back and check your answer. You may either combine those like terms by using your properties as shown in examples 1 and 2, or you can use the circle and underline method that I've shown you as sort of a shortcut by using it directly on the problem itself. Come back and replay the video when you're ready to check your answers. Okay, go ahead and check your answer to part A. And after you've looked that one over, then we'll do part B. Okay, and go ahead and take a look at the answer to part B. Do notice in part B that even though you are adding decimals and fraction coefficients on the variable p, that the negative 5/10 plus the positive 1/2 actually are opposite numbers. So when you add negative 5/10 plus 1/2, you actually get 0. So adding 2/3 to that just is where you get 2/3 in front of p. Also notice that there's nothing to combine with the negative 2 7/500. That term is all alone, so you don't have to do anything with it except make sure it's included in your simplified answer. Now let's move on to example 3. In this example, we're going to combine like terms that include two variables. So we're going to simplify the expression 4a minus 5b minus 6 plus 2b minus 3a. So again, they use the properties to group things together. We're going to do the same thing, but we're going to use our underlines and our circles and another shape in order to combine our like terms. So notice that we have both a's and b's as variables. We can only put a's with other a's and b's with other b's. So I'm going to start by using blue to circle any term and the operation in front of it that has an a. In this case, I have 4a minus 3a. And 4a minus 3a is just 1a. Then I'm going to use red and a box to box in any of the terms that have a b. Again, don't forget to include that operation in front of it. And what we end up with is negative 5b plus 2b, which is a negative 3b. Now notice that the only term left in that expression that we have not used is the subtracting 6. It's a constant term and it's all by itself. It doesn't have anything to go with it, so we don't have to actually do any operations. We just simply have to use it in subtraction. So we should have three parts to our final expression. One term has an A, one term has a B, and one term is a constant term with just a number. So now let's take a look at the final simplified expression. 1A minus 3B minus 6. And you'll notice here that you do not have to include the 1 in front of the A. It's not wrong if you do, but it's not necessary, because anytime you have a single variable, we assume that you have one of that variable unless there is a different coefficient in front. Now I'd like for you to try it for example 3. Simplify that expression. You do not have to use the boxes that are provided there. You may instead do it just directly on the question and then write your simplified work over here. Okay. If you want to fill in the boxes, then when you come back to check your answer, I'll show you how those boxes might look. Try that and pause the video and then come back and check your answer. All right, so take a moment and check over example 3's try it question. You'll notice that I did some work directly on the expression that was given to us, and then off to the right side I showed you how I combined those like terms together. Notice that the 4K does not have anything to go with it, so it just simply is by itself and not combined with any other terms. I also showed you what the boxes would look like if you were to complete the expression that is in your book on that page. And what you end up with as a final answer is negative 5G plus 4K plus 7 4/10. Now let's go on and try some additional questions on the practice and problem solving. The key concept reminds us that when simplifying algebraic expressions, use properties of operations to combine like terms. So we're going to be doing that by grouping those like terms together. You can use whatever method makes the most sense to you as you group your like terms, but notice that you always group x's with other x's, y's with other y's, and constant terms with other constant terms. Make sure that all of them are like terms before you put your coefficients together. All right, your assignment is to try questions 4 through 17 and number 20. We will go over these answers together in class.